Kia ora, Year 12 and 13. This is a question from the 2005 Scholarship Calculus exam, and it's a Conics question. So the question goes like this. An ellipse is drawn around a square so that the minor axis is a diagonal of the square. The area of the ellipse is twice the area of the square. Find the eccentricity of the ellipse. Now you're given two more bits of information that I didn't type up. So the first one is the area of an ellipse is given by a equals pi ab, and you're given the equation for that ellipse, which is the usual, this thing here. And the other thing you're given is a lovely wee picture of what we've got. So there's my ellipse, and here is my square. Now, I could have done that in GeoGebra, but I haven't. So the first thing you'll be wanting to do with that is to pop some axes in. So we'll do that now. Right, now let's read the question again. The minor axis is a diagonal of the square. So there's my diagonal of the square. And our job is to find the eccentricity. So pause it here and try and work out as much as you can about what you're going to do. Okay, let's start by taking a look at the square. Well, the square looks like this, and I know that the diagonal is length 2b. So there are several ways to do this, but one way is to divide that up and say, well, if that must be b and b. We've got a whole lot of right angles, so let's take out a little triangle, and we can see pretty quickly that this length here, call it k, comes from Pythagoras. So k equals b squared plus b squared, so 2b squared. All right, that side length squared plus that one there. So we get k is equal to root 2b. So now we know the side lengths for each of the squares. So the area of square is equal to k squared, which is just this, so 2b squared. So that's all good. Now we're also told the area of the ellipse is a is equal to pi ab, and we're told that that's twice the area of the square. So that's equal to 2 times 2b squared. Right, so we're going to do something with this. Our goal is to figure out the eccentricity of the ellipse. So remember, the eccentricity of the ellipse is a measure of the stretchiness of the ellipse, and it comes from the focus divided by a, so that half the length of the major axis. So c squared is equal to a squared minus b squared. So let's look at what e squared is. So e squared is c squared over a squared. Doesn't really matter, you can work directly with e. It's just a little bit cleaner to go with e squared. So e squared is going to be a squared minus b squared over a squared, which simplifies to 1 minus b squared over a squared. So what we're going to do now is we're going to use this relationship between the two areas here, and we'll make a the subject of that. So we get a equals 4b squared over pi b, which is 4b over pi. Right, so now you should be able to get there from here easily. A squared is equal to 16b squared divided by pi squared. So we are going to take this and we're going to substitute it in there, but I will do that on a new slide. Okay, so e squared is equal to 1 minus b squared over a squared, which equals 1 minus b squared over 16b squared on pi, which equals 1 minus pi. I think I've lost a pi squared in there somewhere. Hang on a sec. Yeah, that should have a pi squared. Okay, sorry everyone. So 1 minus pi squared on 16. So e is equal to the square root of 1 minus pi squared on 16. Thanks for watching.